Hello again, it's David. Now, at the end of my last video where I introduced my STFM board here and I removed the old CPU to replace it with a socket to allow me to install the great tower that is DSTB1 here whilst I was testing. At the end of that video, I showed you this booting up with EmuTOS off floppy, and we were left with the amazing sum of 70 kilobytes of free STRAM. We had our 8 megabytes of AltRAM, but 70 megabytes of STRAM wasn't 70 kilobytes of STRAM wasn't really enough to do very much at all, to be honest. It's barely 2 screens worth. So we need to do something about that. Now I can upgrade the STRAM on this, and I think I think this has had one in the past. The MMU's got some gunk on it, and the straps are missing. There's some solder here and some funny looking resistors over here. So I suspect that's what's happened in the past. It's been restored, but this only has 512K at the moment. It's a bit of a faff to upgrade to 1 meg, although it is possible to do 1 meg without any third-party items. If I remove the PSU there, you'll see that there's actually, that's the 512K, and you'll see that there's another bank there of RAM chips that I could populate along with the bypass caps, and that would give me 1 meg. However, that's only 1 meg. That's a massive faff. Look at all the effort that goes into that. So what I'm going to do instead is the opposite, and to try and basically use less RAM. So there's 512 on there. That's enough for most things, although for example, something like Frontier won't run because it expects to put its screen at a particular address, and that address is not available with 512K. I shall hack it to work, but I mean, at some point I will want to upgrade this, but I probably will use a more modern technique. In the meantime, however, we need to reduce that RAM usage for an operating system that understands AltRAM, i.e. what we have here on the DSTB1, and so the simplest way is to replace the ROM. So this is, I don't think it's original, it's because it's got writing on it, but actually, well, they are Atari chips. So this is TOS 1.2, sometimes referred to as TOS 1.02. This was basically the last revision before they started introducing proper hard disk drivers, and TOS 1.4 was kind of like the final version for the original ST style boards. So this is one step behind this. This was introduced when they released the Mega ST, and it's massively out of date, totally useless, no good to man or beast. So we'll have that out. And what I've got here is a modern extension board from the Exos store. Now this basically replaces the 2 ROM chips. Hello, now this is David from the future. What I was going on about now was a load of nonsense, so I'm coming back to revisit this. What I'm basically saying is this is replacing 2 ROM chips with a single PLCC, and there's a jumper setting there that lets you choose whether you want the upper or the lower half of the PLCC to be served as the ROM. So the PLCC chip is going to be half a megabyte, 512K. The normal ROMs on the STFM are only 192K, so basically we would have to pad up to 256 and then allow that to do the selection. Here is the chip that I'm going to use. This is an erasable version of a 512K PLCC ROM chip. So this is a Hitachi HN 27C4096, and these are very old second-hand chips that I've acquired off eBay. There we go. Yeah, so I haven't clipped that in, but yeah, they do fit. But the chances are that this might have one address line that we need to tie low or high or something. But I'm hoping that will do, and I'll be able to burn myself a copy of EmuTOS and possibly TOS 2.06 on that, both of which support AltRAM, which is crucial for what I'm trying to do. EmuTOS recognise it automatically. So this board is going to go in there. Fortunately, I've already got sockets here. If I were to fit this with sockets, I don't think the keyboard would go in. But elephant in the room. This thing, look at it. Keyboard's not going in with that there anyway, so I don't need to worry about that yet. So I'm just going to build this up now, and we'll compose a flash image, and we will also a ROM image, and we'll try and burn that and see how we go. Okay, so let's have a quick inspection of the board here, and the first thing that it stands out, jumps out at me, is what a nice finish this board has. This is obviously terrible video casting, but it's just got a very nice finish. It feels a little bit heavier perhaps than I'm used to. I don't know. It's odd. It's got a lovely silky smooth top layer, absolutely beautiful bottom layer. It just feels like a nice bit of kit, and I don't know what Exos has done especially, whether he's had a different provider to normal on this. It is this year's stock. I don't know. It makes absolutely no difference whether it was done in the worst possible production facility or the best, but it feels nice. It's very strange. Don't know. I'll have to ask him about that. But this is all you get, right? So this is the starting point. This is what is delivered. So we don't have a jumper for the selector. We will need to choose over here, by the look of it, how we want the ROM selection to happen. So there's a couple of options there. There's aux and glue, and the middle one is presumably actually the ROM, output enable on the chip there. So glue means that it will come. You see it links straight to this pin here. I'm guessing that that's going to be like ROM 1 or not sure, ROM 0 probably, and that indicates the normal chip selector comes from the STFM. An aux allows you to attach an input here and give your own address decoding signal, which we can do because DSTB1 does that. It on one of the test points, I think it's test point 1, we output a TOS 2.06 decoding signal, so I can feed that in there, and what that means is that this chip will trigger when the E0 address range, so that's hex E0 to EF triggers. This will so that's the address range. It's the last or the second to last megabyte of the 16-bit address range. Sorry, the 24-bit address range. That will trigger then, and that's where TOS 1.62, TOS 2, TOS 3, TOS 4 live, whereas TOS 1.4 and below live at a different address range. I think it's FC and FD, I believe. So if we leave it to the glue, that's what will trigger. So I'll probably start with the glue and then might move up, because I can build a version of EmuTOS that lives in that address range. So that's no problem at all. In fact, if you go to their website and download EmuTOS 192, that will live in that address range. And all I've done is I've recompiled it to support AltRAM, which is what I need. So that's how I'm going to start, I think. What we need to do is to solder some pin headers into this, and I've got some offcuts of previous projects here, so I probably will use these rounded pin headers, but they're going into dual wipe sockets rather than turn pin sockets. I don't know whether it's actually better to use square pin headers like this for those kind of sockets. Lovely snug fit there if I were to use that, but I don't know. I'm not 100% sure, so I'll probably just use these ones. And actually, I'm tempted to mount them inverted. I might have to just do a little experiment and see which way round these fit best, because they're nice and short on this side, and they're quite long on that side. So that I will maybe just have a little play with the sockets. I've heard people say if you use these in the dual wipe sockets, then the dual wipe sockets get stuck wider apart. I'll be honest, I'm not that concerned about it, not for the ROM chips. So I'll probably just go down that road. And I've got a whole load of offcuts here from previous projects of those RAM pin connectors, so I'll bodge together enough to fit. This one will just be a standard square pin header to allow me to fit a jumper to it, or you could fit a switch down the road, so you should you so choose. And I might put a DuPont wire. So take a DuPont cable here and chop chop it down and solder it onto there so that I can plug into that end should I so wish. Or maybe I might even fit, I've got a 90 degrees pin header here. I might just could fit a single 90-degree pin header in there and then just plug in from the other board. So that we can always come back to, but I'm going to use glue mode to start with and see how we go. So I'll need to do some investigation when this is all soldered up and find out what sort of chip I can drive in here. It could very well be that one of the pins, like I say, needs to be tied to ground or to VCC or something to disable half of the range. I shall look into that with the multimeter later on. So I think without too much further worrying, let's get these pin headers on. Okay, so because this one doesn't quite fit, I've got a 2 here, and I've just shaved off the edge right at exactly the right point there with the cutters, so that when the 2, that one's pretty good already, when the 2 sit next to each other, maybe that's not quite right, there we go, that one. So when they sit next to each other, they are the correct spacing, and to ensure that before I solder it, what I'm going to do is going to bring in this is an old DFB card that's in the process of being dismantled. But what it has on the back here is a 2.54 pitch socket. So I shall just use that. That's nice and loose because it's meant for square. Pins. So I'm just going to use that as my template, I think. There we go. Hold it nice and square and anchor them down. Okay, and just a quick dab on the outer ones because we don't want to heat that when it's in the socket for too long. And there we go. We can see that that's nice and straight. So we still need to worry about the alignment when we put it at the top. I think that's reasonable enough. These are dual wipe sockets, as I say, so they do have a bit of give. Perhaps for this one, okay, this requires 3. What have I got in my junk bin? Take 3 from this one, I think. So didn't quite get that right. There we go. There's 3, and we've got a little dag that we need to tidy up. So I'll show you what I did. Come in there on the boundary. Try not to cut off too much, otherwise the pin will fall out. Not quite. Let's try again that direction. Try and get this on camera. Okay, a little bit too much on there, but I think that'll be fine. Then we'll present that. Okay, and then this one's just got a little bit of a dag on the end. What's that end look like? This end might be better, actually. Let's try that way around. I'm just trying not to waste these old pins. There we go, they fit all right. Right, I might resort to a breadboard here. I don't like doing this on breadboards because it can melt the breadboard. If you heat it for too long, you've got to be very, very careful. But obviously it's got more holes. So you can do dual in line. Say that, I'm not convinced that this breadboard is actually terrible. I think we'll go that way. No, it has to be that way. Okay, so there we go. We're just going to hold that in place and then repeat the process. Just a couple of dabs of flux. I think it's those 2 boundary. What's that? Okay, that'll just hold them in place now. Okay, look, the alignment is actually not great, but that's why I've only done a couple in case I have to rejig that. And I'll repeat this process now on the other side, and we'll test the alignment in the ST before I solder them all up permanently. Now, whilst I'm doing that, I'll just take a moment to thank the sponsor of this video, PcbWay. PcbWay can provide you excellent quality boards with a very fast turnaround, but that's not the only string to their bow. They also offer CNC machining, sheet metal fabrication, 3D printing, and injection molding. So if you're looking to get your circuit boards manufactured, or indeed another project off the ground, why not have a look at their website? You'll find it linked into the description section of this video. There we go, there's the alignment. It's not the greatest the world's ever seen, but I'll go and test that now, and we'll solder that up permanently if it's fine. Just need to trim these ones down. Okay, so here we go. I've got the other chip out, and this is our board. It's all a bit mucky still. Right, so pin 1 marking is on this side, so that corresponds to the little white notches in the silkscreen here. We'll just try the alignment there. I don't want to push it in, because if I push it all the way in, it's not anchored properly, and we might pull the pins out coming out. But I think that's going to be okay. So they're dual wipe sockets here, so you can see maybe that one there. That's okay, that's inside. That one's inside. I don't think it's perfect. Actually, this one's angled in a little bit, but that one seems to be better aligned than some of the others. I'm going to just go with that, and I think with a bit of gentle persuasion, that's going to fit. Okay, so there we go. That's the main pins in, and okay, the alignment looks reasonable on all of them. Maybe this one's a little bit splayed over here, but I'm sure we can coax that in. So I need to do a little bit of cleaning up. I've got to get the option header in. I happen to have a spare 3-way one laying around there, so that will pop in there now. And what I'll just show you here with this jumper. So the concept of the chip select, chip enable jumper here, you see, is we have to choose one of these. We have to bridge one of these outside ones to the center. So what we do, this is it's not always easy. So let me get you in close and see if I can do this well. So what we try to do is we put a bit of solder on the pad that we're interested in, and the one we've got to bridge it to, and we just wait for that to cool just for a few seconds, and then we just try and overload this one with a bit more. There we go. Just a little bit of dabbing in and out, and that is now bridged, and we'll test that in a moment with the multimeter. Okay, so whilst that's drying off, I've just finished cleaning that up, I'm going to have a look at this reset switch. So down in the corner here, I've just fluxed this up, and I'm going to try desoldering that and putting this replacement part I've got from the Exos store on instead. So that's the new switch. It looks like it's got exactly the same layout. There's 3 pins in the middle, and we've got, so there's the 3 pins, and it's got 2 anchor points diagonally. So there's the 2 anchor points, and there's the 3 in the middle. So what I'm going to do is to get the desoldering pump, the self-heating desoldering pump, into play here, and see how we get on with this. It does look like someone's been in here before, but I've just added some extra flux, so that bit is me. Try not to eject this onto your legs when you've sucked up some solder. A mistake I have frequently made. I doubt this would do it all in one go, you know, completely by itself. But what this might do is to get us 80% of the way there, and we just finish it off with a bit of wick and perhaps even some hot air. Okay, so we've had one go at each. Let's see if it's loose at all. No, that's not loose yet. Let's check the pins. No, I think that middle one has still got a big blob of solder on it. So let's get the wick on it briefly. You can see that is sucking up some solder. Ah, that one's loose. I'm expecting these anchors to be a bit harder. Yeah, still not feeling any movement there. I don't think this would be glued down at all. Let's bring the desoldering pump back in again. No, I think I'm making things worse with this. Okay, I think that most of those pins are now loose. It's just that back one, I think. There we go. Yep, there we go. Just that reverse, that back one was a bit sticky. Okay, so let's get the braid back on that and try and clean some of those up. That pad there, the one nearest you of the actual contacts, that looks a bit ordinary, I'm going to be honest. I think that might be lifted. Maybe not, maybe just one corner of it. Probably enough there to make contact anyway. Right, let's see whether we can fit our new one in. I can see the pins. There we go, straight in. Look at that. Oh, and you can see actually, maybe you can't, sorry, there we go. You can see the pin does actually extend beyond the motherboard on this one, which is how it's supposed to be. So you can see how poorly that last one was doing its job. Let's get that anchor point in place. There we go, that was nice and easy. Well, to me, that looks pretty good. Great. There we go. Shall we buzz those out? Just unplug the desoldering pump before I forget about it. Okay, so here we go. So I'm expecting, I don't actually know how these work, but I'm expecting one of these pair of pins to be shorted when it's out and to break when we push it in. That looks right. I would guess that that is then actually the reset line, and that's probably ground, so that should be open, and then when we close it, excellent. That was a nice little interim fix, wasn't it? Right, so we've got the programmer out and the laptop, and this is obviously the little board we've just built up, and we're going to use this adapter that came with my programmer here. This is the Mini Pro, absolutely ubiquitous Chinese programmer, TL8662+. This is the little adapter that came with it, so DIP40 to PLCC44. This is actually intended for, I think I've shown this before, this is actually intended for microcontrollers. So the pinout is not quite right, so there's a couple of little bodge wires that I needed to do to make it work with EPROMs. However, the newer versions of this have a jump on here, so you can switch between them. So PLCC to DIP40. So what we're going to do is pop my erasable ROM in here. There we go. We're going to pop it in the programmer the correct way around, and we're going to perform a blank check. Need to make sure that we're empty before we can start writing. So I've got my Linux virtual machine up here, and we're going to issue the Mini Pro command -p. It's HN 27C4096 at DIP40 because we've got that adapter in place, and -b is for the blank check. So that'll focus for a second. Yep, okay, here we go. We're going to try that. So it's got the chip ID, okay, it's checking everything, and memory is blank. Excellent. So we can now go ahead and write our, what do I have to do to get focus? Some background in place. So we can go ahead and write our combined swapped image there. So that's going to be -w combined, well, it doesn't support tab completion, combined swap image. And we'll set that going. So there we go, writing code. Now this will take a little while. You'll see the lights on the programmer here burst into life. And we'll let that run through. Let's actually show you how I make this Dual TOS image. So what I've got here is two images that I want to be able to switch between. I've got TOS 1.04, UK variant, and as you can see, that's 192K. I've got EmuTOS 192 UK variant, and again, yeah, 192K. So the first thing we have to do when we inspect these, we'll see that they are in the correct byte order. There's no surprise there. 602E 0104, so that's TOS 1.04. 602E is always how the ROMs start. But when we come to burn this with the Mini Pro, that's a little endian system. We need to invert these. So the way we invert them is using DD. DD conv equals swap byte, swab. We take it input from TOS 1.04, and the output goes to TOS 1.04 swap swap.image. 192k copied. That's all we have to do. Repeat it for the EmuTOS. Swap.image. There we go. And when we look now, you see if I do an ls minus lh human readable, there we go. They're all 192k, except this time, if we were to look at the swap entry, for example, you'll see that it's now, instead of 602e, it's now 2e60, and instead of 1.04, it's now 1 there and 4 there. So the bytes order is swapped. Now, after that, we need to pad these to 256k. Our ROM image, our ROM itself, the 27C4096, the 4096 is kilobits. That implies it's a 512k ROM. We're going to split it in two and use the high half and the low half. So we need two 256k images. So the next thing to do is to pad our swapped images here to 256k, and the easiest way to do this on a Linux system is to use the truncate. There's plenty of other ways you could create. Using again DD, you could create, for example, the balance in zeros and append them. But I'm going to use the truncate here. So truncate minus s 256k TOS 1.04 UK swap image. Now if we inspect, there we go, it's 256k. If we hex dump it again, and we skip to the end, we'll see, look, here we go. After the end of TOS, we've just got a whole load of zeros until, or 3F, F, 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 which would be the 256k. So, say that. Right. So that's the EmuTOS, sorry, that's the TOS one done. Need to do the same with EmuTOS now. So truncate minus s 256k ETOS 192 UK swap dot image, and there we go. Lovely stuff. We've got 256k images. Now all we have to do is to join them together to make a combined swap, and the simplest way to do that is cat. So cat TOS 1.04 UK swap with EmuTOS 192 swap, and we'll make that into one called combined dash swap dot image. That's it. And now when we inspect those, we'll see combined swap image is 512k, and if we were to hex dump them at the start, we've got our TOS 1.04. There'll be a big old gap in the middle, and then we'll end up with the EmuTOS one and the second half of the image. So there we go. It'll hopefully finish burning by now. Okay, so let's pop the EPROM out of here. And we'll try and mount it. It's not 100% dry yet by the look of things. Or maybe it just needs a bit better of a clean. I think that's maybe just a little bit of flux residue still. Oh well, if it causes problems, it's going to have to go back for a bit of a better clean anyway. Yeah, that's, I can feel that's a bit sticky. I think that's going to need a far better clean. But okay, here we go. Let's try it out. So there's the notch. There's the notch. So this should line up like that. There we go. Snap that into place. That's not as positive a contact as I'm used to. That seems to be riding quite high. But these are decent sockets on here, so fingers crossed that that's fine. Then we're going to need a jumper for the selection there. Sure, I can find a jumper somewhere. There we go. So I'm going to select block 1 on the completely unjustified assumption that will be the first block of 256k in this 512k. I think I was saying a megabyte earlier on. 512K chip, two 256s, and what we've got is two 192 kilobyte TOS images padded to 256 and concatenated. So this will now slot in, looking at the pin 1 markers, this should now slot in this direction. And I'm going to have a quick look on the side, and it's going to need a little bit of sideways pressure, I think. There we go. So, fingers crossed, let's be brave. There we are. We are in. So double check, we've got the pin 1 marker this way, we're in block 1, we've got it set to glue select, and everything seems nice and snug. I think it's time to try it out. Okay, so I'm afraid this is one of those situations where I'm going to please nobody. I've got the board set up here, we've got the power supply in place, we've got the mono VGA adapter in place, obviously we've got our new adapter here, I've got the Gotek, and DSTB1 is still connected, keyboard's in, but I can't show you this and the screen. So what should we go for? Should we do the screen? Cross our fingers. So here is the VGA screen. We're obviously expecting this to be ST high mono mode, and I'm going to throw the switch on the power supply, and I'm going to plug it in remotely in case I have to whip it out a bit quickly. So here we go, connector going in. Okay, green light on the keyboard, green light on the monitor. We've got white screen. Voila! Well, there's no other TOS chips in there, so that must be booting from our new device. It's got to be booting from there. So, well, the easy trick is, what TOS version do we have? Oh, but unfortunately, because I'm in high resolution mode, I won't get to see the rainbow TOS logo. Oops. 85, 86, 87, 88, 89. I don't remember. It's in low and color mode. Sorry, in low resolution mode, you get a nice rainbow effect on the Atari logo there. Ooh. Keyboard jumped. Why don't we throw the jumper and try EmuTOS, see whether that works. So I'm going to just put the power off here, and there it goes. And I'm switching the jumper over. Jumper is switched. Fingers crossed, what do we get? Power's on, green light on the keyboard, green light on here. EmuTOS! It's a double thumbs up. There we go, and look at that, we've even picked up our 8 megabytes of AltRAM. And my keyboard's gone again. Oh, we've got a flaky connection here. I think I've got a loose I've got a load of DuPont cables connected to each other here to extend the keyboard lead, and I think they're a bit loose. There we go. So EmuTOS, look at this, perfect. And if we look at the oh no, not there. This is a very cut down version of EmuTOS, obviously to fit in the 192K, even though we've got 256 here. I don't know whether it would decode that successfully. So it doesn't have the bit where it tells me the what's the word? The amount of memory spare, but we did see 8 megabytes allocated initially. So let's switch our Gotek around a bit and see whether we can get sysinfo to run now, or whether that requires STRAM, which would be annoying. So what have we got on here? Sysinfo. So Control A, sysinfo.app. Let's try that. That's probably the more modern one. Now, of course, what we should have here, different to when we tested this before, is that we should now have 512K of actual STRAM, which is enough to run front bench. Still can't do that yet. I'll have to recode that to allocate memory dynamically. But we we should be able now to run a few more things. We had 70k free before. We should have about 400k free now, I think. Okay, let's have a look. Hardware, memory. There we go. RAM total 524. That's STRAM. 367 free. After loading this, that's an improvement. So it's 367 kilobytes free after loading a program. Previously we had 70 kilobytes free before doing anything. And we've got, there we go, look at that, 7.9 megabytes free in the AltRAM, giving us a total of over 8 megabytes of free RAM in total. So there we go. By getting that into ROM, we've saved ourselves a whole lot of things. So what else can I try in here? Let's. So I'm pretty sure front bench won't work here anyway because it's mono, but I know for a fact that the reason front bench works with AltRAM is because it has a fixed address where it accesses the screen, which is why we don't get the crash. But we can try GenBench, and let's do the CPU test. Now I should say, whilst this is running, that the chip I'm using here is an 85 nanosecond ROM chip, which means, I believe, if my mental arithmetic is correct, that we should be able to not slow down when accessing the ROM. Now, this is what Exos does with his ROM expansions. He basically insists that you install fast ROM when you have one of his boosters installed, and that means that he doesn't slow down when accessing it. Now, 85 nanoseconds is that's about 1.5 cycles at 16 megahertz, but remember the minimum cycle time on a 68000 is two cycles from the address strobe going low to the data being latched, or the data being available to be latched. I think actually it might be 3 cycles. I can't remember off the top of my head. But anyway, plenty. So I think I could actually tweak the firmware to access the ROM here at basically not slowing down to run at full pace. I probably won't do that just for compatibility's sake, but as an experiment, you know, it's feasible now. Well, that's interesting. That wasn't a statistic I was expecting to see. So we've run from AltRAM. Our ROM access is 100%, or just over, because we run from AltRAM, which I was expecting. Our integer division is just over 200 because we run from AltRAM, so the instructions execute faster. But our RAM access has come back as 206%. And our AltRAM has come back as nothing there, and yet we ran from AltRAM. Curious. I wonder if it's doing something based on the TOS version here. TOS, our EmuTOS is identifying itself as 1.04. That might have been a mistake. I might have to burn a version that says it's TOS 2.06. I've got a sneaky suspicion that perhaps GenBench, I'll have to ask, perhaps GenBench is going, well, TOS 1.4 can't have any AltRAM. So I'll just allocate RAM normally and test it. And of course we're getting the AltRAM speed as the STRAM test. But there we go. Very happy with that. So I hope that was of interest, and we can certainly do some more tests on different combinations of ROM now that we have this available. We can perhaps look at doing the TOS 2.06 decoder. So that would involve using one of these flywires, although I think these are actually test point 2 and 3, so I need another flywire that would come over here and do the external trigger, which would allow us to, well, not only TOS 2.06 but also the 512 version of EmuTOS to be used, potentially even with another little with an attachment to address 18 to the center pin there. That would potentially allow us to address the full 0.5 megabyte of EmuTOS as well, so you get all the features, which might be nice. I'll potentially have a look at that in the future as well. But there we go. I hope that was revealing, and I've now got myself a system I can test with, and I've got myself a reset button that works. Great success all around. See you next time.